What's up, pre-calc? I'm your man, Steve Harvey. I'm just kidding. But I like to watch Family Feud, so if you guys ever want to talk about that, let me know. All right, so we're going to deal with properties of our log functions, logarithmic functions. Remember, they are inverses, right? So when you had x squared and x to the third, this ended up being x to the fifth because you had to add those, right? So multiplying, add. Take a look at this one right here, right? So if we are multiplying, we got to add this thing. We're going to have to ignore that phone because we're rolling here, guys. So keeping that in mind, so our division is going to require some subtractions. We can separate those, and this is the one that's going to be handy for dealing with this. So our exponent becomes the coefficient out in front, and we just want to make sure that if we have log base b of r is equal to log base b of s, right? Since these are the same base, that means r is the same thing as s. So we can drop those and figure that out. Inverse property, the exponents of logs, right? So notice some matching here, and grab the old highlighter. Right, if I match the base and the of, and same thing here, then we're going to get just x. So let's figure out, way back in Algebra 2, you did some intro to logs here, so here they are. So subtraction, what's that mean? That means division, right? And these should be as a single logarithm. So I want log of 3 over x, done. Right, so 3 divided by x. So we're going to kind of translate and work our brains that way. If we are adding natural log, so that means I should multiply 5 and y to get 5y. This is, my friends, this is a coefficient. So it's going to become the exponent log base z of 1/4. All right, now that might not be there because we know the 1/4 is actually the fourth root in the first power. So it may be hidden as a square root. So we have to work with those just a little bit as well. All right, now we start to layer them in here. So you see a lot of stuff going on. So 3 becomes the exponent. So this is log base 5 of x cubed plus log base 5 of y to the second. And now I am adding these together. So that means I should multiply the of parts. So log base 5 of x cubed y squared. Okay, so if you remember and you get going with this, we can skip that middle step. Try not to do that too early because this may be somewhat new or feel a little bit new. Here we go. We're going to distribute here. That means this is the fifth power on both of these. So it's natural log x to the fifth, y to the 10th minus the natural log of y to the negative second and z. Well, let's use second. And then what we'll do is we'll use this to put those in the denominator. And then we'll have to reduce, it looks like y's. So the natural log, I get x to the fifth, y to the 10th. We're going to put y to the second and z squared in the bottom. And let me finish this and I'll talk about that. So natural log x to the fifth is all by itself. We're going to reduce here to get y to the eighth on top and z squared. All right, so let me go back and talk about what I was thinking about doing here. Is I could take this up as -2. And what would happen is when I get over here, I'm going to get -2 y to the negative second and z to the negative second. So I can put these together this way, noticing z doesn't have anything, so it ends up in the denominator, and dealing with my y's this way. So I can do that. Really doesn't matter. It's kind of personal preference. So just got to make sure that both of these terms end up in the denominator if we're going to do it the original way. If you like to distribute with a negative, you can do it that way too. All right, that's kind of the nice thing about it. All right, so that kind of leads us through our properties. Then the next thing we have is most calculators, okay, especially something like this, they're really good for log base 10. Well, what we can do here is we can take and use any log base and rewrite it. So of course I want to use log base 10 for these base a's, or I might change the whole thing back out until the natural log. So either way works. So we're going to practice is this would be a log of 16 over a log of 3. Now notice no base means a base of 10. So that means we can actually get these. So we do log 16. Oh, I should probably turn that on. I guess we're going to just make sure you guys are good using the calculator. Log of 16. Okay. Most times you have to either hit enter or close your parentheses and divide it by log of 3. That one you don't have to close. Okay, but you should get 2.524 if I round it. Okay, typically we're going to go out 3 decimal places as we work with these. All right, so we got log 2 over log 1/2. All right, I try and make this pretty simple with my students. Say, right, so this is the top, right, and then this is the bottom. You want log of the large number over log of the base number. So not really meaning large as in the value. So log 2 divided by log 0.5 might work there. So I'm going to get -1 as my final answer. All right, so if that's working on your calculator, then you're doing pretty good. All right, so what happens is now that we can take and kind of separate these guys here, we can actually graph things that we couldn't do before. And I'm going to take you through that real quick and show you how that works. So what we're going to do is use change of base, right? Because obviously this goes right into that. So we're going to use change of base. So this is log of x over log of 5. And I'm just going to run a through here. So that means I can separate these, right? Because this is actually 1 over log of 5 times log of x. Right? So I can graph log of x because we can make a table out of that. And what happens is this first number, so if I do 1 divided by log of 5, right, I'm going to find out that actually becomes 1.431 times log of x. All right, so it's multiplied out in front, so that becomes a vertical stretch. So what I have over here, I grabbed this little screenshot from the book, I hope that's all right, is notice the blue one is vertically stretched a little bit taller. So we have that happen because we can separate these. All right, so you can tell with the next one, there's going to be lots of weird stuff going on. So let's take a look at it and see what happens. All right, stop moving around. All right, so first thing is log of x. All right, so this would be over log of 1/4. All right, and that's going to be, right, 1 over log of 1/4 times log of x. So let's find out what 1 divided by log of, let's use 0.25, right? That's going to be a whole lot easier to put in here. All right, 1 divided by log 0.25. All right, so that turns out to be negative 1.661 times log of x. So what's that mean? That means it should be stretched, right? So this is greater than 1, so it's going to be stretched. But this part here gives you an x-axis reflection. So that means it's going to go upside down. So notice again, the black one we have up top here, that's our original function of a log. And what we did here is we already showed you the reflection because we're going to have that negative. And okay, so the blue one down here is log of x. So let me go through that one. So that's a log of x. So we have stretched it vertically, and then we also flipped it over so we can start to do that. All right, so we're going to go ahead and turn the first part of it into some sort of number that's going to then tell us whether it's stretched or compressed. Right? These could end up being less than 1, so we could deal with that as well. All right, I think that gets us through everything we need for the lesson. Go ahead and give some of these a try if you're ready for it. If not, we'll cover it in class. All right, all right.